Hello, and welcome back to another episode of Kerbal Space Programming. Kevin here, and in the last episode, one of you mentioned in the comments that we don't get to see many disasters anymore. In the most recent videos, most of what I've been commenting on has been pre-recorded, the stuff that I've already gone through and I've tried and trialed out, and as a result, it gets kind of boring because we already know it's going to work, and it's almost, why even bother showing it, because obviously I've had the time to go through and perfect this. Well, it just so happens that in this episode, we had a little bit of a catastrophe. You see, we've got this second craft that is going to dock with our new space station in orbit, and it is trying to slow down. If we watch the target speed, it is trying to come in, and the humanity, or more importantly, the Kerbality. That's a little... All right. Well, yes, so I've been having some issues with recording footage, and you may notice that this video is actually 720 rather than 1080 because I've ended up switching software and I forgot to switch the settings there. But this is a clip that I managed to get of our first trial run at docking another craft to the station. You see it is still running its program, trying valiantly to make its way to the correct docking port, and it is failing miserably. But with that disaster out of the way, I think we should jump back into the start of this mission. Okay, so yes, everything went fairly well. We are launching on a slightly modified version of our standard launcher. You'll notice that there are 4 side boosters rather than the standard 2, and it almost looks like there's no bottom fairing. Oh no, it's just the light being a little weird. It almost looks like the bottom fairing was missing, but that's not the case. This was a bit of a nightmare of recording, because with a lot of these, the reason that so much of this is post commentary is that running these trials is we're running over programs that can take upwards of 10, 20, sometimes even 30 minutes to run to completion, at which point maybe then we discover that there's a bug or that there's some sort of catastrophe that causes the whole thing to crash. Combining that with some recording issues means that it is very difficult to talk over that length of time, all to discover that I've got to repeat myself over again. And I obviously don't want to run the risk of boring you by repeating myself and saying things that are redundant. So this craft is our habitation module for the station, and it's got a lander can, and then it's got the Mark II version of the habitat for planes, which does not have an accessible way to get it in and out, which is why we need the docking port. Now, because I had to adjust the ascent profile for this many times because we're delivering a heavier payload and using the additional boosters, which required a fair bit of tweaking, but and I'm not going to show that because all of that code is in the repository if you are curious to take a look, but we've done plenty of ascents in the past. But one of the things worth noticing is that our apoapsis is actually very high, and if we set this as the target, I was worried about having to go ahead and set us up with a maneuver node to intercept, but if we set up a maneuver node and we don't tweak it, we just right-click and we advance by a couple of orbits, we can actually see, there we go, click, there we go, come on, pass Kevin, you can do it. And we can see that this intercept is actually getting closer, and it turns out that the intersection that we get, just by random happenstance, happens to be very close. So we don't even have to set up an intercept maneuver, we just have to be able to cancel out our relative velocity. So let's jump over to script land and start figuring out how to do that with our engines. So the first thing that I went ahead and did is I snagged some code from an episode from quite a while ago. I believe it was episode 10. I'll put a link up here in case you haven't had a chance to see it, where basically we rendezvoused with a craft using fuel rather than RCS, so that we could rescue a Kerbal from the orbit of Kerbin. And we didn't have to really worry about near approaches because we could switch over to the derelict craft, and then the Kerbal would EVA over to our rescue craft. But we had these these functions, and we never really extracted them into a library. So I've put them in here and we've cleaned them up just a little bit, and I'm going to walk through kind of what we have here. So the first thing, and this is actually something that I think we could find useful in a bunch of locations, remember how occasionally it takes us a while to steer in a direction that we're trying to go, and what we'd do is we'd just say lock the steering to a certain direction, and then we'd just say wait 10 seconds or 5 seconds, and we just sort of tweak what that number was so that we'd make sure we don't start firing the engine until enough time has passed that we're guessing we're pointed in the right way. Well, what we can do instead is we can say, here's a function called rendezvous steer, and it's going to take a parameter, it's going to take a vector, which is really what we're doing when we say lock steering to up. We can also point it at a vector, because a vector is just a direction and a magnitude, that we don't really care about what the magnitude is. We're going to say go ahead and lock the steering to the vector. But now we're going to say also wait until the vector angle, which we've talked about in previous episodes, between the ship's facing forward direction and the vector that we want to be steering at is less than 2. So now this is going to block any remaining code until we are pointed within 2 degrees of the direction that we're supposed to be steering in. So now we no longer have to say, okay, point this way and then wait 30 seconds, because it's going to vary based on the craft and based on how much steering control that it has. Now we know we're just going to wait until we know we're pointed in the right direction. So this is more of a helper function that we can use for our other rendezvous tasks. So there are 3 other functions in here that are going to use this rendezvous steer. Now, it's also important to note that because we're passing this in as a parameter, if we try and pass it in something that we have locked, if we say, lock to the direction of the vessel, well, once we've finished this up, this is going to be a fixed value. We're passing it in as an argument, and so that means that if we lock the steering to here and then the vector changes, this steering is not going to update. So we only want to use this once, and we're going to want to relock the steering after we know that we're pointed in the right direction to start with. So this first one is approach, and this is really kind of a rehash of the stuff that we've done in the previous episodes, but we're making it a little bit better because now we have these vectors to play with. So we're going to lock our relative velocity to our craft's velocity minus, the target craft's velocity, orbital velocity, minus our own orbital velocity. This lets us know how fast we are going relative to the craft. We're going to use that rendezvous steer function to point us at the craft's position. And then once this is done, once we're pointed in the direction, we're also going to relock the steering to the craft position. And now this will reevaluate every time that it looks to figure out where it should be pointing. And now we're going to go ahead and lock our throttle. Now we want to lock our throttle not to full speed because, we could overshoot. We're passing in the speed at which we want to approach as one of the arguments. And what we want to do is we want to make sure that we don't fire full throttle too long and end up going much faster than we intended. So what we're going to do is we're going to take our ship's maximum thrust, and we're going to divide it by the mass of our ship to get the acceleration, the maximum acceleration if we were at full throttle. Now we're going to lock throttle to the lesser of 2 values. So it could be 1, or it could be the absolute value. This is a little bit messy, but the absolute value of the speed minus the relative velocity's magnitude. So that's the speed at which we are already going. So if we want to be going 10 and we're going 5, well, then we say we want to go 5, and then we want to divide that by the maximum acceleration. Now, what this means is that as we approach what that target speed is, if we're going 9.9, well, then the throttle we're going to set to 0.00 something, right? But if we are very, very far away from our target speed, well, then we're going to go ahead and throttle very, very high. And we've capped this by saying take the lesser value, this minimum function of 1, or whatever this formula gives us. So this means we will throttle down as we approach the speed that we're trying to go, but we're never going to try and throttle to more than 1 because we can't really do that. Now we're just going to wait until our relative velocity's magnitude is greater than the speed minus 0.1. And this is just some fuzziness to make sure that it doesn't need to be completely equal. Then we'll lock the throttle to steering, and we're going to we'll lock the throttle to 0. We'll throttle off, and then we'll lock our steering to the relative velocity. And this is going to point us directly away from our velocity vector, and that means that when we go ahead to cancel out our approach, we're already pointed in the right direction. Now we have the rendezvous cancel function. This takes the target craft that we're trying to hit. We're going to do copying a bunch of the same stuff here. We're grabbing a relative velocity. We're going to steer against our relative velocity and lock the steering again. We're going to get our maximum acceleration, and then we're going to lock the throttle to the relative velocity divided by the maximum acceleration, or 1. And this is so we're going to be pointed away from the vessel, and we're going to fire up until our speed is effectively 0. And we're, again, locking this so that we make sure that we don't throttle so far that we suddenly start drifting away from the craft. And now we're going to wait until that relative velocity is less than 0.1. So it may not be exactly 0, but we're getting pretty darn close, and we know that now we've pretty much stopped relative to the target craft. And then the last function that we have here is rendezvous await nearest. This is going to take the craft again and a minimum distance. And what we've got here is we say until 0. This is the same as saying until false, but it's fewer characters to type. Until false, we're going to say set the last distance to the craft's current distance. We're going to wait half a second, and then we're going to say, all right, well, now if the distance is greater than it was 0.5 seconds ago, or if the craft's distance is less than the minimum distance, well, then we'll go ahead and break out of this loop. So what this will do is it'll say, all right, if we're going to wait until our closest approach, and if we start drifting further away from the craft, well, then we want to go ahead and break out of this loop, because presumably we want to do something else. But it also gives us the ability to say there's a minimum distance at which I don't even care if we're still approaching the target. We need to stop now. If we imagine that we're 2 meters away from the craft and we're still approaching it, well, this would go, we're not quite at our closest approach, so I'm just going to go ahead and wait here indefinitely, and then we could run the risk of crashing into the craft, which is not what we want to do. So we can make sure that we get our closest approach, but only within a particular margin, and at that point, we'll go ahead and break out of this. So this is just extracting some of the stuff that we've already sort of done, cleaning it up, and using some more of these vectors to make them a little bit nicer. And now we can use them to get ourselves an approach that relies on RCS, and then we can use RCS for just kind of the final refining approach before we dock. So here's the Habitat rendezvous script that's going to use both our rendezvous library that we just made and our docking library that we've made in previous episodes. Now, first, we're going to go ahead and delete our maneuver and ascent libraries because they're taking up space on our hard drive, and we want to make sure that we've got room for these new libraries that we're going to be using. We're going to set KSS core to vessel KSS core. This is the station that's already in orbit. We're going to notify that we are awaiting the flyby. So remember, we looked and saw that our maneuver node put us relatively close. I think it was a distance of maybe 12,000 meters or 12 kilometers. So we're going to say, just wait until we're within 15 kilometers. And at that point, we're going to say, okay, now we want to start refining our approach and bringing ourselves in until we are within 500 meters. So we're going to say until KSS core distance is less than 500, we'll say we're killing our relative velocity. And we're going to call that rendezvous cancel function. That's going to point us in the opposite direction of our relative velocity and fire until it is close to 0. Then we'll say we're making our approach with fuel. We're saying, all right, approach this vessel with a speed of 30. And remember, then as soon as it's done, it's going to point again opposite the direction of our relative velocity. And now we're going to say just wait until we are at our nearest approach. So we're going to await the nearest, but we're also going to say if you get within 500, then it's going to go ahead and drop out of this function, and then it'll go ahead and start all over again. So this loop will continue to go over and over and over. It'll kill our relative velocity, approach it at a speed of 30, and then stop and wait and do that over and over and over again. Once we get within 500 meters, we're also going to make sure that we cancel relative velocity because we could be going 30 meters a second, and that can be a little bit difficult for RCS to handle on this large craft. So we'll cancel our velocity one final time, and now we'll say we're going to initiate the docking procedure. We're going to do the docking just like we did in the last episode. We're going to give it the HAB port, which is the one that we want to control from. We're going to give it the name of the vessel that we want to dock with, and I've named the port that we're going to dock with on the station KSS side port. So this is all that we're doing. We're using our rendezvous script to get ourselves a very close approach, and then we're going to use our docking library to bring it in with RCS. And now back in spaceship world, we can go ahead and warp around until we get to our near approach, just waiting those 3 orbits, and we end up very, very close. And now our as soon as we get within that, there we go, that 15 kilometer range, it's going to go ahead and start canceling out our relative velocity and then approaching and doing all that wonderful stuff. Now you saw at the beginning of this video that this is a script that we were running where disasters happened, and the reason for that is that this craft is far heavier than the items that we docked with in previous episodes. And in our dock function, which we developed, we had hard-coded in these various values that when we're making our initial approach, we can go in and approach at a speed of 10, and then we'll approach at a speed of 5 when we're closer, and et cetera, et cetera, et cetera. Now, the problem is that because this thing is so massive that it takes an awful lot of RCS and an awful lot of time for us to change our velocity that drastically. And it brings up an interesting point about library functions versus kind of general mission scripts, and that is that with library functions, you generally want to make them very, very generic, very general, so that they don't, so that they should work with kind of anything that you, with any sort of craft, and that if you have issues like this where the behavior is going to change based on the performance of the craft, well, then you need to make sure that you can either pass the things in as variables, or maybe they just don't belong in a library at all, and that you should set up those procedures within your actual mission script, which is probably what we should have done. In this case, what I went ahead and did is go into our docking script and just tune those approach speed values down for our RCS down to very, very small. So I think we're making our 200 meter approach at a speed of 1 meter per second. And even then, that's going to take a little bit for the RCS to get it under control. But you see, now we're in range, and so we're back to our good old traditional docking procedure with the RCS, which we've run in previous episodes, so we can watch this thing sort of float in. But you'll see now we are approaching at a much lower speed. But it was an interesting conundrum, because the stuff that we have in our library folder is supposed to be kind of there generally so that we can use it across various videos. And I don't want to make any changes that will break previous videos by making adjustments to our library. So this was one case where if you tried to go back and use that script in the future, in our previous video where we docked, it's still going to work. It's just going to go even more slowly than it did in the previous videos. But there are a couple of changes. Yeah, and I'm going in here and cheating and turning off the solar panels just because I realized that, yeah, we're docking in a place where that's a little bit dangerous. Now, of course, our side ports on the craft, on the station, I should say, are much more protected. But because this is part of the core of the station, we actually do want to be rather careful as we make our approach. But no, as I was saying, there's just an issue in that we want to try and make sure that we don't ever have to make breaking changes to our library. And in this case, I was kind of pushing the edge of that. But yeah, there we go. Okay, so we're aligning, we're coming in, and okay, we're making our side swipe maneuver. And this, of course, is all under 4 times time acceleration. This is, again, part of why you don't get a ton of live commentary with these docking maneuvers, is because, yes, we went from, we did an entire rendezvous and a docking with a single script, which is very, very cool, but also means that this is a 30-minute task to run and then script, which, yes, and, you know, and potentially in collisions. And you may also notice here that we are doing a side swipe that doesn't seem to make a lot of sense. In fact, it seems like we're putting ourselves in front of the craft, and I'm not entirely sure why that is. I think there's probably something wrong with the way that we're picking our side swipe maneuver. It's probably something that we'll need to go investigate, but that will also necessitate a change to our library script, which does make things a little messy. But you can see this actually does have a little tiny, a smaller port. Okay, and we are at least, yes, we're avoiding the solar panels this time. We're bringing ourselves around. The idea is that we can park the tug on these little smaller ports and free up the remaining docking ports for actual docking and etc. But this has life support from TAC Life Support, and it has these capacity for 3 Kerbals. And then, yes, there's also a big bunch of RCS hanging out the bottom of it, just because we managed to deplete a whole bunch of resources on that last time. And yeah, man, wouldn't we? Our doc script has some built-in bias about just how much range there should be. And this is really one of those cases where it is probably not appropriate, because it's really a matter of, it's really sort of mission specific as to what the range should be when we're trying to do these sorts of maneuvers. And so probably isn't the sort of thing that belongs in a library, or at least belongs as a configurable component in the library. There we go. We are docking. And huzzah! We have docked. And of course, it is all sorts of askew, but we can start transferring in our monopropellant such that our tug can start doing more tug stuff. And we have our station sort of starting to shape up. So let's go ahead and grab a quick script to get our tug out of the way of the large docking port and put it on the hab. So back in scripting world, we're doing kind of what I was talking about, and that is not using our dock script, but rather using the components, because then we can customize them for our particular needs. So we set our target port to the service port. We set our docking port to the tugboat small port. And then we're just going to notify we're docking, we turn on the RCS, and we're going to ensure a range not of 200, because there's no reason that we need to be that distant. We're going to approach the port. And again, we can tweak these speed values now so that it kind of applies more to our specific situation. This may be a case where we eventually want to rewrite our dock script or function to accept a list of parameters in the same way that our ascent profile did, where the ascent profile manages actually executing those steps, but we can pass those in as a configuration. But we've got this going. Let's go ahead and shuffle around our tugboat. So here we are undocking, and I've gone ahead and tweaked the tag names on some of these ports and stuff, but we can see it's pulling away and getting to a range of 50, which is still probably overkill, but certainly a lot less inefficient than our 200 meter safe distance that we had hard-coded. And you see it is coming in, but it is also somewhat off-center as far as rotation goes, and this is something that we just didn't have handled in our docking script. Not really a problem for this tug because it's relatively small, but it will be a problem when we shuffle our habitation model to be the core base of this station. So it's docked, but let's go ahead and see if we can adjust our script to make that a little bit better. Alrighty, so rather than actually look at a script here, I'm going to type git status, because I'm using git to manage these files so that I can make updates over time and kind of incrementally save them. So I'm going to type this, and you can see that it shows a list of the files that have changed since the last time that I uploaded stuff to the GitHub, and it shows that I've modified the docking library. So I'm going to go ahead and say git diff. Well, let me go ahead and clear this so it doesn't end up taking up too much space. But I'll say git diff library docking.ks, and this will actually show me all the various changes that I've surreptitiously made to these. So you can see in red it's showing items that have been subtracted, and in green it's showing items that have been added. And you can see down here at the bottom, you can see that I've adjusted the values for these sideswipe ports. Mainly I've adjusted that final parameter, which is the speed, and that was what was causing the collision at the very top of things. We've changed the ensure range to take the speed down from 10 to 1, because that was... yeah, that sent us into the panels. But you can also see that I've gone ahead and made a change to our dock approach port, and that is that we were locking steering to the opposite of the port-facing vector, which is great. But if you think about it, a vector is just a direction. There is nothing to say this direction, and also, by the way, we want to be, oriented rotation-wise in the same direction as the port. Now, we have a function that we get from KOS, which is look_dir up, which takes two vectors. One is the direction that we want to be facing, but the other one is the direction that should be up on our craft. And so by providing those two vectors, we're doing the same thing. We're just saying I still want to be pointed at the target port-facing vector, the opposite of that. But I also want to make sure that I am pointed up based on the target port's up-facing vector. And this should mean that our docking ports are aligned, which means that when we go ahead and dock, we're not going to be super askew. It's not a huge issue for our tugboat because it's relatively small, but our hab it's going to be a lot more critical, because we need to make sure that the entrance point for the Kerbals is not going to be covered by a solar panel. So we want to make sure that we can actually be confident in what our rotation is relative to that docking port. So now that we've gone ahead and done that, we're going to run the exact same script against our tugboat, just to test and make sure that now when it goes ahead and redocks, it'll actually align itself with the docking port. So now we go ahead and run the same thing again. We let this thing undock, and I upload the script, at which point it should, there we go, it's taking itself out to range again, and now it's going to come in and dock, but this time it should actually align itself with the upward direction, so that the upward direction on its docking port is the same as the upward direction on the target docking port, which means that we should be aligned, which is great. This means that when we go ahead and dock any future craft, won't end up at some weird angle relative to the port. So there we go, we're bringing it in, and look at that. It looks to be reasonably aligned, right in line with the rotation of that craft. That is wonderful. And now we can go ahead and start adjusting some more tags, because we're going to move this hab section to the base there. And as soon as I go ahead and do that, now we're going to run the exact same script. And we can see now we've got the main habitation module, which has the docking port stuck on the side of it. We're now moving that to the bottom of the station, because this is going to be kind of the core body. And there we go. It is running its maneuver, getting out there to its 50-kilometer range, and it is aligning. And now, if you're being particularly astute, you can see that we are aligned correctly, but unfortunately, when I place this thing in the VAB, I set the docking port 90 degrees from where it should be. And now the EVA port on the lander can is right behind where one of those solar panels will extend. We actually need to be 90 degrees rotated from the correct direction, which is frustrating because now we can't use our docking library to do that. So we're going to have to go in and create a tweaky custom script to fix this. Okay, so here we are in the KSS Hab rotation script, and unfortunately, even though now we've modified our docking library to make sure that we're aligned in the correct direction, the port is not in the correct direction, and we actually need an offset from this. This is maybe a case where we need even more configuration in our library, but instead I've gone ahead and just copied and pasted our approach port from the docking library, and I've called it custom approach port. And then just the modification that has been made is that we're lock steering, instead of to the up vector of the target port, we're locking it to the starboard vector of the port, because it is 90 degrees from where it is supposed to be, which is unfortunate. That's really a matter of I should have made sure to place it correctly in the vehicle assembly building before getting it out into space, where it makes scripting a lot more of a pain. And then we're going to do the exact same thing that we did before with the tugboat, and this is what we did when we were doing the initial shuffle with the hab as well. The only change is that we're using custom approach port rather than the regular approach port. But there we go. Once we run this, we should finally have this thing aligned correctly, and our station will be nearly complete. Alrighty, so one last time, we'll go ahead and undock and let it go ahead and start doing its thing all over again, bringing itself back in. But this should be kind of the whole core of our station. It'd be nice to get a fuel depot docked to the back of this, but we see now we're actually coming in and we're aligned, and we can see the port on the lander can, which is actually going to be facing the front or back, I don't know, it doesn't really matter, of the station, which won't collide with the solar panels, which is exactly what we want. Finally, we have our station starting to look a bit nicer, and we can see it's still got those side docking ports for visitors, and we can go ahead and start clearing out some of the construction materials in future episodes. But we also need to start thinking about getting ourselves a minor small station around the moon so that we can start doing landings over there, manned landings, Kerbal landings over there. So we will go ahead and continue on with this in the next episode. Until then, cheers.